Okay, so everyone is clear about the graphs of inverse triple functions? Yes or no?
Yes.
Okay, what about the principal, value, domain, and range? Everyone? Please read it through once. Okay, let me draw a table. We have function, domain, and range. Okay, function, domain, and range. If we have sine inverse x, then what is the domain of sine inverse x? What is the domain of sine inverse x?
-1 to 1.
-1 to 1. Closed brackets. Very good. And what is the range?
-π/2 to π/2.
Very good. What about cos inverse x?
-1 to 1.
-1 to 1. And range is?
Good evening, sir.
Good evening, Rishita. All good?
Yes, sir. What about you?
I'm also good. You are late today?
Yes, sir. My PC was not connecting. It was not charged, and it was not working.
Okay, you have revised all the graphs and principal, range, and domain?
No, sir. I didn't get to watching the lectures because my exams just completed today.
Okay, okay, okay. Don't worry. Just go to the last lecture, okay? Get the video. And I'm also writing the principal, domain, and range here. We have started sine in trigonometry. So sine inverse x, domain is -1 to 1, range is -π/2 to π/2. Okay.
Yes, sir.
Cos inverse x is -1 to 1, and range is 0 to π. Okay.
Yes, sir.
Cosec inverse x, we have all real numbers. Yes. -1. And what about the range?
-π/2 π/2 -z0.
Is it closed or open?
Closed.
Very good. Sec inverse. This is C.
In domain
And here is 0 to π.
π, excluding π/2.
Very good. Tan inverse x, we have r -π/2 to π/2. What inverse x? All real numbers, 0 to π, open brackets. Okay. So you can see these two same domain, same domain, same domain. Range, these three are almost similar range, and these three almost similar range. Okay. And very important to know the range. Note it down, everyone. Done, everyone? Okay. So this chapter, if you want to be good at this chapter and the chapters that are coming in future, then you should remember the properties. Okay. This chapter will always revolve around properties. If you know which property to apply, then all the questions can be solved very easily. If you do not remember the properties, then life is very tough. Okay. So we'll discuss some properties. Property 1. We have first one, sine inverse sine theta, and this is theta. When theta belongs to minus pi by 2, pi by 2. Okay. Sine inverse sine theta is equal to theta when theta belongs to minus pi by 2 to pi by 2. You can see the proof also. Let's say x is sine theta. Okay. Or I can say sine theta is x, then theta is sine in x. Okay. If we take x as again sine theta, sine inverse x is sine theta. So we get this value that sine inverse sine theta is theta. Please note it down. Similar way, we have cos inverse cos theta, which is equals to theta, and theta belongs to 0 to pi. And this is very important. Remember, theta always belongs to the principal value, range, or domain. Okay, depending on the properties. Third one, tan inverse tan theta. This is theta, and it belongs to minus pi by 2 to pi by 2. Fourth one, cot inverse cot theta, which is theta, and theta belongs to 0 to pi. Cosec inverse cosec theta is again theta, and theta belongs to minus pi by 2 to pi by 2 except 0. Then we have sec inverse sec theta, which is theta, and theta belongs to 0 to pi minus pi by 2. Note it down. Done, everyone? Okay, second property. Now remember, in this property, theta always belongs to the principal domain. Okay, so it's very important for you to know the principal range. Okay, so very important to note that second property, it's the opposite of that, which is sine of sine inverse x is always x, where x belongs to -1 to 1. Cos of cos inverse x is also x, where x belongs to -1 to 1. Tan of tan inverse x, which is x, x belongs to r. Cot of cot inverse x, again this is x, x belongs to r. Fifth one, cosec of cosec inverse x, and this x belongs, sorry, x, where x belongs to r minus -1 to 1. Sixth one, sec of sec inverse x is also x when x belongs to r minus -1 to 1. Please note it down. Done, everyone? Yes or no?
Yes, sir.
Okay, let's do a few questions on this. Have sine inverse sine pi by 3. Okay, Rishita, which property is applicable here?
So the last one. Uh,
Last property.
as in secant sine inverse and sine get cancelled.
Right, but remember, when sine inverse sine theta we have, which is property 1, then theta should belong to which angle? Minus pi by 2 to pi by 2. Okay, otherwise this is not applicable. All right.
Yes, sir.
So here, does theta belong to minus pi by 2 to pi by 2?
No, sir.
No, minus pi by 2, pi by 2. Does pi
Yes.
by 3 lie inside this or outside this?
It lies inside it.
So that means it belongs to minus pi by 2 to pi by 2, right?
Yes, sir.
So we can directly write the answer is theta, just pi by 3. Okay.
Yes, sir.
All right. Insha, Rafia, Zaina.
Done, sir.
Okay. Let's do another question. If you guys understood this, cos inverse cos of 2 pi by 3. Okay, try to solve it.
Pi by 6.
Okay, so here we have cos inverse cos 2 pi by 3. What is the principal range of cos inverse? It is 0 to pi, right? Now 2 pi by 3 lies between 0 to pi or not? Yes. So the answer will be 2 pi by itself. Okay. Okay.
Yes, sir.
Okay. More question. We have sine inverse sine of 2 pi by 3. Try to solve. Pi by 3. Correct answer is now. So here we have theta, which is 2 pi by 3. And we have sine inverse. That means it should be from minus pi by 2 to pi by 2. but 2 pi by 3 is beyond this, so we cannot use the formula directly. The answer cannot be 2 pi by 3. So what we have to do this is, please see this very carefully. We have to convert this with some angle which lies between these two. And how do we do this? Always write the numerator with a multiple of denominator, closest multiple of denominator. So in the denominator we have 3, numerator is 2. So we can write sine inverse sine 3 pi, because closest to 3, closest to 2 is 3, right? So 3 pi, but we have 2 pi, that means 3 pi minus pi. I can write 2 pi as 3 pi minus pi. Please remember this very important step. 3 pi minus pi. I write 2 pi as 3 pi minus pi, and denominator was 3. Now this is sine inverse sine 3 pi by 3 minus pi by 3. So now we have sine inverse sine, this is pi minus pi by 3. Now you have class 11th formula, pi minus theta, sine of pi minus theta. This becomes sine theta itself, right? In the second quadrant, sine is positive. If you have multiple of pi, sine remains sine. Does everyone know this? Yes or
Yes.
no?
Yes.
Okay. So it becomes sine inverse sine theta, which is pi by 3. Now pi by 3 lies between minus pi by 2 to, so it becomes pi by 3. Okay, this is the right answer. Is everyone clear about this?
Yes.
Okay. Note it down. Okay. Sine inverse 1 by 2. Please find the answer to this. Find principal values of the following things. Sine inverse 1 by 2. For the answer, anyone? One by two we can write as sine pi by 6, right? Sine 30 degree, sine pi by 6. And pi by 6 lies between minus pi by 2 to pi by 2. So the answer is pi by 6. Okay? Yes?
Yes, sir.
Yes, sir.
Cos inverse root 3 by 2.
Pi by 6.
Correct answer. Okay. Everyone got it? Pi by 6? Yes or no?
Yes, sir.
Sine of sine inverse 5 upon 13. What is the answer here? Pi by 13 itself. Yes or no? You guys understand this?
Yes, sir.
Yes.
Okay,
Yes, sir.
why is it 5 by 13?
Because it's inside pi by 2 and minus pi by 2.
In the
No,
range.
no. See, here we will use property number 2 because we have sine of sine inverse x, right? Property 2, sine of sine inverse x, and x belongs to -1 to 1. That is why the number is outside as it is. Okay, please be careful. Okay, guys.
Yes, sir.
Yes, sir.
Okay, then another question. Let's see who can do this. Sine of cos inverse 4 by 5. Try to solve it. Think about class 10th and also. Okay, and I'll give you one more hint. First try, then I'll give you one more hint. Remember, the property is sine of sine something, then the something is outside. This is the hint I'll give you.
It will be 3 by 5.
Yes, very good. Everyone got it?
Yes, sir.
No, sir.
No. Okay. See, this is a trick for Investigo chapter. Whenever you are stuck, whenever, whatever the question may be, always assume the given thing as x. What I mean by this, let's say this is x. X is cos inverse 4 by 5. That means cos x is 4 by 5. We know trigonometry more than we know Investigo, right? So we can draw a triangle here. Cos theta is based upon hypotenuse. So this will be 3. This is x. If cos x is 4 by 5, sin x will be 3 by 5. So x will be again sin inverse 3 by 5. And x was what? Cos inverse 4 by 5. So cos
Sir,
inverse 4 by 5. Yes,
sir, can we use this property which is like cos equals to pi by 2 minus sine x?
sin inverse x. Yes, you can use that, but then again, you have to find the angle, right? You will write here pi minus pi by 2 minus cos sin inverse 4 by 5. Then what will you do? Sine of pi minus theta. Sine of pi minus theta, sine theta. Yes, that can also work. Yes, that can also work. Okay. But remember to not make any mistakes when questions diverge. Okay, that method is fine, you can use that, but sometimes what happens, you will get pi plus something, then you have to use sine also, right? Sine pi plus theta is minus sine theta, so you have to take care of this also. Okay, if you are able to do that carefully, then that is fine.
Yes, sir.
So this becomes sine inverse 3 upon 5, so the answer is 3 by 5. Okay, very good, Rishita. Everyone else, is it clear?
Yes, sir. Yes, sir.
Okay. One more property. Property 3. Sine inverse minus x, and this becomes minus sine inverse x. X belongs to -1 to 1. Tan inverse minus x becomes tan inverse x, so minus tan inverse x. X belongs to R. Cosec inverse minus x becomes minus cosec inverse x, so x belongs to R minus 1 to 1. Fourth one we have cos inverse minus x, it becomes pi minus cos inverse x, x belongs to -1 to 1. Cot inverse minus x is also pi minus cot inverse x, where x belongs to r. Sec inverse minus x is also pi minus inverse x, since x belongs to r minus -1 to. Please note it down. Done, everyone?
Yes, sir.
Let's see its proof also. So again, the same trick. Let sine inverse minus x be theta. So we can say sine theta is minus x, or I can say x is minus sine theta, or I can say sine minus theta. So we can say if x is sine of minus theta, then sine inverse x is minus theta, and theta was what? Sine inverse minus x. So minus of sine inverse minus x. So we can say, we can take this negative to this side. So sine inverse minus of sine inverse x is sine inverse minus x. Okay, hence proved. So using this method, we can prove anything in Investigo and life becomes easy. Please note it down. Okay. If this proof is understood, then try to prove the cos inverse property. Cos inverse minus x, proof 2 is pi minus cos inverse x. Please try to prove this. I'll give you a few minutes. Done, everyone? Again, we can do the same thing. Cos inverse minus x is theta. So we can say cos theta is minus x, or we can say x is minus cos theta, or we can say this is cos of pi minus theta, because we know cos pi minus theta is minus cos theta. Okay.
Yes, sir.
So we say cos inverse x is pi minus theta. So cos inverse x is pi minus theta is what? Cos inverse minus x. So you can bring this to this side and this to this side, and it becomes the same property. Okay. Please note it down.